Adipic acid is a compound of 49.31% carbon and 47.79% oxygen, the rest being hydrogen. The molar mass is 146.1 grams per mole. What are the molecular and empirical formulas? So to go about solving this problem, I'm going to take the different percentages of each element, carbon and oxygen, and the remaining hydrogen, which I can get by subtracting both of the other percentages from 100, and multiply them by the molar mass of adipic acid, this compound. That will give me the grams in 1 mole of that compound, which I can then divide by the molar mass of the individual element, and I will get a whole number. And the reason I will get a whole number is because the very idea of an atom is that it is indivisible. So when I add if I think about a molar mass of something, I'm basically taking the individual atoms that make up that compound and then adding up their molar masses. I'm never going to not get a whole number of molecules that make up a compound. Like water, I'm not going to get an oxygen and 2.5 hydrogens, because that element is supposed to be an element is indivisible. So every time I do that and I divide by the molar mass, once I have the grams of carbon that make up that compound, I should get a whole number. And this will be very easily seen, I guess, when I just do this problem, which I should just get on doing. So I'm going to take carbon, convert the percentage into a decimal, multiply it by the molar mass, and I get 72.04 grams a mole. So for every 1 mole of this acid, 72.04 grams per mole of it is carbon. So to figure out the number of carbon atoms that make up this compound, I'm going to divide by the molar mass of carbon. And I get 6. And it should always be a whole number. If it's not a whole number, then I've done something wrong. Because I'm not going to have, like as I said before, I'm not going to have a compound with half an atom of carbon. It's just not going to happen. So if I see something like that where it may not be exact, it may be 5.9999 or something like that, which is what I got in this example. And that can be rounded up. That's close enough. Does not have to be precisely 6. So next I'm going to do oxygen, convert this into percent, 4779 times the same molar mass, and I get 63.98. And now I do the same operation, molar mass of oxygen, and this gives me 4 oxygens. And then for the hydrogen, I add both of these together, 47.79 and 49.31, and then I subtract that value from 100, and it will give me the percentage of hydrogen, which is 6.9. So I'll convert that into a decimal and then multiply it by the molar mass. .09 or 0.8. And this is a little bit scrunched, so I'm just going to move this down over here. And this is equal to 10 hydrogens. Now I have the molecular formula. And it is C6H10O4. But if I wanted to think of it as, or if I wanted to know what the smallest repeating unit of this formula is, I would have to get it in its lowest terms. And here I can see that oxygen is the smallest number, but it's not going to divide evenly out by 4. So what I'm going to do is look for common factors, and I can see that 2 is 1. So I'm just going to divide everything by 2, and it'll give me the empirical formula, which is C3, which is 6 divided by 2, H5, 10 divided by 2, and O2, 4 divided by 2. And this is as low as it will get. And I can't divide it anymore, otherwise I'll get parts of atoms. I have 2.5 carbons, or or if I divide it by 2, and then I'd have 3 over 2 carbons, which is not going to happen. So this is my final answer.